Example 1.30. Obtain the formula for the electric field due to a long thin wire of uniform linear charge density lambda without using Gauss's law. Using Gauss's law, આપણે આ equation already derive કરેલું છે અને એકદમ સિમ્પલેસ્ટ વેમાં આપણને ઇક્વેશન મળી ગયું હતું. આ પ્રોબ્લેમ સોલ્વ કરીશું એટલે આપણને ગોસીસ લો નું ઇમ્પોર્ટન્સ ખ્યાલ આવશે કે કેટલું ઈઝી પડે આપણને. Gauss's law is very useful to find the electric field at any point due to symmetric charge distribution. હવે જો અત્યારે આપણે without using Gauss's law electric field find out કરીએ. Now see, this one is uniform linear charged wire, okay, having linear charge density lambda. Now suppose we want to find the electric field at point P, which one is at perpendicular distance r from the wire. Okay. Now here we consider the origin x equal to 0 here. With respect to that, on y-axis we take point P, which one is at distance r. Okay, wire is coinciding with x-axis. Now here we have to divide this entire wire into so many infinitesimal small line elements. Then due to each line element, which one is charged one, we have to find the electric field at point P. And then after, we have to take vector summation of all those fields to calculate the resultant electric field. This one is the concept. Now see, first we consider here infinitesimal small line element having length equal to dx, on which charge residing, that is dq. And with respect to this particular element, suppose point P is at a distance a and this element is at a distance x from the origin. Then electric field due to charge dq, which we can consider now point like charge because this element is infinitesimal small. So dE, that is k dq upon a square. So 1 upon 4 pi epsilon 0 into dq. Now charge per unit length is lambda. Therefore, charge on length dx is how much? So lambda into dx. So dq, that is lambda into dx. Then a. So we can use Pythagoras theorem. A square, that is r square plus x square. So this is the electric field at point P due to charge dq. This charge dq is positive. It implies that at point P the electric field will be outward. So direction of the electric field dE, that will be as shown in the figure. Here this angle is considered theta, so this angle will be also theta. So we can take two components of the electric field dE, one that is in y direction dE cos theta because this angle is theta, and another one in this x direction, specifically it will be in negative x direction, that is dE sin theta. But see here, we can consider another infinitesimal small element, which one is at a distance minus x from the origin with same length equal to dx. So charge on it, that will be also dq. And due to that electric field, that will be in the direction which one is represented here by black arrow. Now if we take two components for this electric field, then one dE cos theta will be in y direction in the direction of this particular component of the first electric field. Then dE sine theta will be opposite to this first dE sine theta component. It implies that dE sine theta components will be cancelled. dE cos theta, these components perpendicular to the wire in y direction will sustain. But the components which are parallel to the wire, dE sine theta, will be cancelled. It implies that now we can say the contribution in the electric field of this particular element, that will be only dE cos theta, because dE sine theta will be cancelled by similar other element. So we can write now dE dash, this one is the electric field due to this small element having length dx with charge dq, that is dE cos theta at point P. So dE dash, that is, now substitute the value of dE, that is 1 upon 4 pi epsilon 0 lambda dx upon r square plus x square, cos theta that is adjacent upon hypotenuse. So that is r upon under root r square plus x square. Resultantly, we will get 1 upon 4 pi epsilon 0 lambda r dx upon r square plus x square raised to 3 by 2. These two jointly will give you raised to 3 by 2. Now to find out the resultant electric field at P, we have to consider this type of so many infinitesimal small elements starting from x equal to 0 to x equal to infinity, as well as on left hand side starting from x equal to 0 to x equal to minus infinity. And then after we have to take the summation of all those. It implies that we have to integrate this equation between the limits minus infinity to plus infinity. But for that integration, we have to change the variables. Okay. Now see, in figure we can observe this thing tan theta, that is x by r, opposite upon adjacent. So x equal to r tan theta. So we can write dx, that is r sec square theta d theta, differentiation of this one. Now r square plus x square, that we can write r square, substitute the value of this x. So x square, that is r square tan square theta. So resultantly we can write that is r square into 1 plus tan square theta. But 1 plus tan square theta, that is sec square theta. So r square plus x square, that is r square sec square theta. So r square plus x square raised to 3 by 2, that is r square sec square theta raised to 3 by 2, that is r cube sec cube theta. It implies that here x is changed in theta, because integration from minus infinity to plus infinity, that will be somewhat complex one. Now see our equation, that is dE dash equal to 1 upon 4 pi epsilon 0 lambda r dx upon r square plus x square raised to 3 by 2. હવે આ બધી જ વેલ્યુઝ આપણે જે ચેન્જ કરીએ એમાં સબસ્ટિટ્યુટ કરીએ. dE dash equal to 1 upon 4 pi epsilon 0 lambda as it is, r as it is, dx. So see, this is the value of dx, r sec square theta d theta. So r sec square theta d theta upon r square plus x square raised to 3 by 2. See, this r square plus x square raised to 3 by 2, that comes to r cube sec cube theta. So r cube sec cube theta. So here this r square. So r square cancelled. So 1 r will be there. sec square theta, sec cube theta. So in denominator, sec theta will be there. Resultantly, we will get dE dash equal to 1 upon 4 pi epsilon 0 lambda by r cos theta d theta. Now, if the variable is changed, limit will be changed. Now see here. If x tends to infinity, suppose we take x somewhere here, element distance somewhere here, then we have to join the line like this. So this particular angle theta will increase. So if this particular end of the wire is extended up to infinity, then here this particular line joining to P and the element at infinity, that will be almost parallel to the wire. And if it is almost parallel to the wire, then this theta tends to pi by 2. On this side, we can write theta tends to minus pi by 2. It implies that now if x tends to plus infinity, theta tends to plus pi by 2. X tends to minus infinity, theta tends to minus pi by 2. So integration of this equation, now that we have to carry out between minus pi by 2 to plus pi by 2. So resultant electric field E, that is integration minus pi by 2 to plus pi by 2 dE dash. But in that, lambda upon 4 pi epsilon 0 r, that is constant. So take it outside the integration. Integration minus pi by 2 to plus pi by 2 cos theta d theta. Lambda upon 4 pi epsilon 0 as it is. Integration of cos theta, that is sin theta, limits minus pi by 2 to plus pi by 2. Lambda upon 4 pi epsilon 0 as it is. First theta equal to upper limit, so sin pi by 2, then minus theta equal to lower limit, so sin minus pi by 2. Sin minus pi by 2, that is minus 1, so minus minus plus. Resultantly, we will get lambda upon 4 pi epsilon 0, 1 plus 1. So resultant electric field E, that is lambda upon 2 pi epsilon 0 r. In vector form, we can write vector E, that is lambda upon 2 pi epsilon 0 r, r caret, where r caret is the unit vector in the direction of electric field. So lengthy calculations, but by using Gauss's law, simply we can calculate this electric field. Clear to all of you?